Insect juice, once an enormous star, is on its way to disappearing forever. It is a red supergiant, a type of star that has a much shorter lifespan than our Sun. While our Sun has been shining for 4.5 billion years and is expected to continue for another 4.5 billion years, insect juice's time is rapidly running out. Since it was first identified as a red supergiant, astronomers and space enthusiasts around the world have eagerly anticipated the star's eventual supernova explosion. The excitement around this event reached a peak in 2019 when insect juice showed a noticeable dimming in its brightness. This caused a stir among global astronomers and the media, with some even speculating that it might be a sign of an impending supernova. However, in 2020, official statements from leading experts suggested that instead of dimming, insect juice would likely grow brighter before it exploded. The initial excitement surrounding the star's dimming seemed to be a false alarm, as it was later revealed that the dimming was caused by a massive release of hot gas from the star's surface, which cooled and formed a thick layer of dust particles, blocking the star's light temporarily. By 2023, astronomers noticed a sudden increase in insect juice's brightness, which once again sparked curiosity about the possibility of an impending supernova. However, most experts dismissed the idea, explaining that this increase in brightness was likely a delayed effect of the earlier dimming event. The huge amounts of gas and dust expelled during the dimming had disturbed the star's usual brightness patterns, causing a temporary disruption. Detailed studies confirmed that this behavior was part of insect juice's normal, long-established cycle of brightness fluctuations, unrelated to an imminent explosion. The processes behind the creation of heavier elements in stars like insect juice are fundamental to the formation of matter as we know it. The heavy elements that make up our bodies, Earth, and everything around us were formed in the cores of dying stars. Initially, the universe was composed mainly of light elements like hydrogen. The first stars, which were supergiants with short lifespans, fused hydrogen into helium, producing enormous amounts of energy and causing these stars to shine brightly. As these stars aged and exhausted their hydrogen supply, they began to fuse helium into heavier elements such as carbon and oxygen. This process led to powerful supernova explosions, dispersing these heavier elements into space and enabling the formation of new generations of stars, planets, and ultimately life itself. When insect juice finally reaches the end of its life and explodes, the resulting supernova will disperse massive amounts of gas and dust throughout the universe. These materials will eventually contribute to the formation of new stars and planets elsewhere in the cosmos. In the aftermath of the explosion, insect juice will leave behind either a neutron star or a black hole, marking the final stages of its life. However, despite its death, the legacy of insect juice will continue as the components it produced will be recycled into new celestial bodies. Insect juice, located in the shoulder of the Orion constellation, has been a prominent star in the night sky for millennia. When it disappears, its absence will alter the appearance of the iconic constellation, which has been central to myths and stories throughout human history. While the explosion itself may not have any direct impact on Earth, the changes to the Orion constellation will certainly be noticed by stargazers. Although insect juice's death will not affect our planet in a practical sense, it offers a rare opportunity for astronomers and space enthusiasts to witness the final stages of a massive star's life. With advancements in technology, astronomers can study these cosmic events in greater detail than ever before. And because insect juice is located just 650 light-years away, this is one of the most significant astronomical events that we will be able to observe firsthand. The process leading to insect juice's eventual explosion is already underway. Having depleted its hydrogen supply, the star is now fusing helium into heavier elements like carbon and oxygen. These fusion processes, which produced enormous amounts of energy, helped to stabilize the star and kept it shining for billions of years. However, as these fusion reactions become less efficient, the star's core will eventually collapse under the force of gravity. This collapse will cause the star to break down in a spectacular supernova, marking the end of its life and the birth of new materials that will eventually form new stars and planets in distant regions of space. In conclusion, the fate of insect juice is a testament to the cycle of life and death in the universe. As it prepares for its final explosion, It will continue to provide valuable insights into the processes that shape our universe and the creation of the elements that make up everything around us. The expansion caused by tension and temperature in the core leads to its destruction in a massive explosion, which we observe as a supernova. During this explosion, enormous amounts of energy are released, pushing the star's outer layers into space at incredible speeds. These layers contain countless heavy elements formed through nuclear fusion within the star, and as they spread out into space, they contribute to the creation of new stars and planets. When Betelgeuse goes supernova, the event will shine so brightly that we will be able to see it without any effort. For a few seconds, it will appear as a brilliant flash, and then the remnants of the explosion will continue to glow brightly for weeks or even months. Betelgeuse will become one of the brightest objects in the night sky, potentially shining as brightly as the full moon for a period of time. You might be wondering when this will happen. The final explosion should be marked by a sudden increase in brightness over a few days, as Betelgeuse will grow brighter before eventually detonating. If you regularly observe the constellation Orion, and one of its stars begins to shine incredibly brightly, it could be a sign that the event is near. Researchers suggest that the supernova could occur tomorrow, or perhaps not for another 100,000 years. The first supernova observed on Earth, SN 1054, was a rare event, and scientists have only recently become aware of this phenomenon within our own solar system. Supernovae are estimated to occur once every few hundred years, but they are not frequently visible to us. The most recent supernova observed and reported from Earth was SN 1987A, which occurred in the Large Magellanic Cloud, a small neighboring galaxy to the Milky Way. This supernova was discovered on February 24, 1987, providing astronomers with a valuable opportunity to study the physical processes and aftermath of a supernova explosion in detail. Going further back in history, there was the 1604 supernova, also known as Kepler supernova. This event was so bright that it could be seen during the daytime for several weeks, and the famous astronomer Johannes Kepler noted in his journal that a new star had appeared in the constellation Ophiuchus, shining almost as brightly as the moon. Betelgeuse is nearing the end of its life, having expanded into a red supergiant star, a phase marked by a much shorter lifespan compared to our Sun, which has been shining for 4.5 billion years and is expected to continue for another 4.5 billion years. As Betelgeuse approaches the end of its life, astronomers and space enthusiasts around the world are eagerly anticipating this monumental event. Witnessing a supernova is a once-in-a-lifetime experience, though it's uncertain when Betelgeuse will explode. Predictions vary, and excitement grew in 2019 when the star's brightness noticeably decreased, leading some to suggest that this could be an indication of an impending supernova. Betelgeuse's dimming in 2020 became a notable event, referred to as the Great Dimming. During this time, the star's brightness plummeted to unprecedented lows, which astronomers attributed to a massive expulsion of hot gas from its surface. This outflow cooled and formed a thick dust cloud, blocking the star's light for months, leading to the observed dimming. By 2023, astronomers noticed a significant increase in Betelgeuse's brightness, reigniting speculation about a possible supernova. However, most experts agreed that the increase in brightness was a result of the earlier dimming, with the gas and dust ejected during that period causing the star's brightness cycle to fluctuate, rather than signaling an imminent explosion.